Okay, let's add a few more details to this story about toilet-linked anaerobic digester, or TLAD. This is an interpretive summary of the socio-technical opportunities and challenges for adoption of toilet-linked anaerobic digesters from the responses in this case study, and arranged into most frequently and less frequently talked about by the participants. These are very region-specific, culture-specific, religion-specific, socioeconomic strata-specific, and so on. And there are lots of studies that have talked about, in general, the challenges of socio-technical transitions to new energy systems and so on. So you can look those up, but here more specifically about toilet-linked anaerobic digesters. That's what is the focus here, and the study is from Nepal, so you can see it will be very specific to this region, even though it has a lot of commonalities to other countries in the region. So the opportunities obviously include improved health, improved ease and comfort, so reduced labor. Costs would be reduced, which would be acceptable for people who are poor. Improved emotions and feelings, well, this is what people listed. Improved sanitation, do not have to empty the toilet and find somewhere to dispose of the waste, so they don't always have piped out wastewater out of the house, especially in the mountains, so they have to manually do these things, whereas the TLAD would eliminate that process. Socio-cultural norms can adapt and change. Modernization and education can happen, so that offers an opportunity. Toilet as a motivator and not only as a source of pollution, so open defecation can be reduced, but also one of our most common mundane chores of defecating can be used as a way to produce energy out of the waste. Demonstration contextualizes economic capital and practical benefits. Open defecation free campaigns encourage TLAD adoption. Safer than LPG. Normalization of gaseous fuel. Observed priests using LPG. So there are people who have moved from typical wood biomass for some sacred rituals to using LPG, which is already a transition to modern priesthood, I suppose. In terms of challenges, cost, so initial implementation and repairs, continued repairs to maintain. Not enough biogas produced for all cooking. This is always the case because you may not have enough feedstock per family when it is directly linked to one household's toilet. Migration, so loss of cattle and manpower. This is common for many of the communities here. Taboos, which we talked about. Using biogas for religious cooking is not always possible. Lack of training reduces resilience of users to diversify feedstock. Drives users to make decisions on feelings, which is always tough in terms of understanding the mental model to making these socio-technical transitions. Structure made of cement makes them immovable and vulnerable to damage. As you know, Nepal has experienced many compound events like earthquakes, heavy floods, mudslides, or droughts and failure of crops and so on and so forth, which all play into these implementations of TLADs as well. Underground structure means repairs are difficult because they must be dug up. Finding technicians to fix them is not always easy, especially in remote mountain villages. TLADs require a lot of space. They may not have enough space in their land. Competition with LPG. Users can see that biogas is made from toilet waste, so LPG feedstock is unknown to them. It just arrives in a cylinder and they think it's clean, so it's just a mental adjustment. Cold temperatures reduce biogas production because digestion becomes harder in these cold Himalayan regions. Older generations take longer to transition, and using slurry on crops where it touches the edible parts is considered very unacceptable and can result in E. coli contamination and other total coliform and health issues. Okay, so what are the adaptation pathways? So we will basically look at adoption pathways to initial adoption of toilet-linked anaerobic digesters, and secondary adoptions, increased or diversified use of TLAD, biogas, and slurry. So we will come from the primary pathways over cumulative time to the secondary adoption pathways. But first, looking at primary initial adoption pathways, higher level influences include normalization of gaseous fuels through increased LPG prevalence, sanitation campaigns, TLAD marketing programs, incentivizing people to adopt TLADs, training and maintenance, geographical adoption context in terms of typical village structure. If the houses are attached to each other, where do you put the toilet, how do you link the TLAD to that, and so on and so forth. The drivers include knowledge and experience, and over cumulative time you can see it can become easier in terms of adoptions, number of adoptions, and acceptance. Influences include technical performance and available alternatives like cheaper LPG, for example, if it is subsidized by the government, and of course there are socio-cultural norms. So you have to always look for risk takers, leaders, or early adopters as they're called, for initial acceptance and adoption of TLAD. And you also need demonstration to raise awareness and provide guarantees that this is safe, clean, and there is nothing unhygienic about the fact that it is coming from human waste. Local people employed as TLAD technicians can help in terms of the acceptance as well as economic employment opportunities. In the secondary adoption pathways, we have technical performance and available alternatives again, and again with time this can increase in terms of acceptance. So we have co-evolving relation between, let's say, priests using using LPG, normalizing gas fuels for religious cooking, which can be a big step forward in accepting non-biofuel, non-wood burning fire for these things. Modernization, weakening of cultural practices and changing attitudes may co-evolve together. Demonstration and experience matters in terms of socio-cultural norms again. So the pathways include again risk takers and leaders, going to biogas and slurry used for more and more practices. Absence of alternatives in certain villages, remote villages especially, may drive adoption. Surplus biogas generated, what to do with those, and more advanced technical knowledge which may come along. So the barriers include LPG being more affordable and acceptable a priori, and there are other available alternative fertilizers instead of the slurry, for example. So this is just a brief introduction, of course, and since this is an introductory course and I'm just trying to bring about various levels of climate solutions, especially these human urine and human waste being related to our impact on the environment. So the solutions here are to reduce our impact, but also to recycle some of our own waste back into fertilizers and biogas, and do it in a sustainable way while cleaning up the environment and improving on cultural practices like open defecation and reducing impacts on health, water quality, soil quality, with additional co-benefits like slurry and fertilizers and so on. So we just keep I will just keep adding these sorts of solutions as they get published under these new findings section of this course, which obviously has to be a living course, because climate change science will keep getting advanced, especially in terms of knowledge of extremes and their predictions and projections, emissions gaps, carbon emission reduction pathways, and other solutions for food, water, energy, health, and transportation. So those are the kinds of things I will keep posting. Okay, let's stop this here for now.